The Sun is a massive, flaming sphere of gases, 330,000 times more massive than the Earth. At its core, the Sun is 27 million degrees Fahrenheit, which is 60,000 times the temperature of your oven when you bake a pizza. The Sun gives off lots of energy into space as heat and light, called solar energy. If we could capture all of the solar energy that reaches the Earth's surface, we could continuously run a 25-inch television on every square meter of the Earth and still have energy left over. Right now, we aren't using all this energy. Instead, we mostly rely on coal, oil, natural gas, and other resources. But these sources aren't renewable, which means they'll eventually run out. In fact, if we keep using these non-renewable resources at the rate we are now, we may run out of oil and gas in the next 50 or so years, and coal in the next 115 years. Not only are these non-renewable resources going to run out, they're also polluting our planet and contributing to climate change. The Sun's energy, on the other hand, will not run out for the next 5 billion years. That makes it a renewable resource. Other renewable resources, like wind and water, can also provide us with energy. But even all the energy we can get from all these sources added together is still less than 1% of the solar energy reaching the Earth. It's clear that the potential of solar energy massively outshines its competitors. How exactly do we harness solar energy? Solar panels directly convert sunlight into usable electricity using special materials like silicon. Another way to harness solar energy is through a process called concentrated solar power, which uses thousands of mirrors to reflect sunlight onto a tower. The heat captured in the tower makes steam that flows through a steam turbine, which generates electricity. But even though we have these promising technologies to capture solar energy, there are still many challenges with using solar energy on a large scale. For example, the amount of solar energy we can harness can change based on place and time. Some parts of the world get much more sun than others. Solar panels in the Sahara Desert will produce more energy than those in Seattle. But even in the sunniest places, the sunlight still isn't constant. The changing of seasons, the cycle from day to night, and even clouds in the sky can reduce the amount of available energy. To make solar energy usable, when and where it's less available, we need to improve energy storage and transmission systems. Above all, we also need to make solar technologies more efficient and less expensive.
Solar energy is energy from the sun's radiation. This energy can be harnessed as solar thermal energy, collecting the heat from the sun, and as solar photovoltaic or solar PV that uses the light from the sun. The most common form of solar energy that we are familiar with is the solar water heater. A solar water heater is a form of solar thermal energy that uses the heat from the sun to heat water. It does not generate electricity. A solar water heater is a better choice if you only need to heat water, as it is more cost effective than solar PV at heating water. Solar PV, on the other hand, uses sunlight and not heat to generate electricity. It is this technology that we use to generate electricity from our residential, commercial, and industrial rooftops. Let us understand how rooftop solar PV works. Solar panels generate DC power when the sun shines. This DC power is in turn fed into an inverter that converts it into AC power. This AC power is fed into your distribution board, from where it flows to your electrical loads. This is the basic layout of a solar plant. It should be noted that a solar plant will need, in most cases, some backup power source. The backup power source could be the grid, for instance, or a storage mechanism such as batteries. Why is this backup required? This is where we need to consider the peculiar way in which solar plants work. Sunshine is not constant. It varies during the day due to meteorological conditions. A passing cloud can reduce the amount of sunshine hitting your solar panels, reducing the power generated. This variation in generation may, in some situations, be severe enough to damage connected loads. In order to avoid this problem, the power from a solar plant is augmented with power from another source. This source can be grid power, diesel, or even battery power. By using this blend of solar power and another source of power, we can ensure that our loads receive steady, safe, reliable power. Now that we have understood how solar plants work, we can see how solar plants integrate with different kinds of power. The simplest kind of plant integrates only with grid power and has no other backup power source. This is known as a grid-tied plant as it is always in sync with the grid. We would recommend this plant only for organizations that have a guaranteed supply of grid power. A pure grid-tied solar plant will not suit you if you suffer from frequent power interruptions, as such a plant will not work when the grid does not work. Another type of solar plant is the off-grid solar plant that does not integrate with grid power. Instead, it only integrates with batteries or a diesel generator. Such a plant can be used in locations that are not connected to the grid at all. We do not recommend off-grid plants unless you are running very small loads, just a few lights and fans for instance. This brings us to the third type of solar plant known as the hybrid plant. Here, the solar plant can integrate with grid power, battery and diesel power. We recommend hybrid solar plants for energy consumers who have grid power but with frequent interruptions and who need critical loads to be powered continuously. Kinds of solar plants, let us consider an interesting question. What would happen if a grid-tied plant did not receive grid power? The answer is simple. In the absence of grid power, the grid-tied solar plant will not generate solar power even if the sun is shining brightly. What would happen if an off-grid plant, which is not connected to the grid at all, did not receive both battery and diesel power? It will not generate electricity. If, however, the plant receives either battery power or diesel power, the plant can generate electricity. And finally, what would happen if a hybrid solar plant, which can integrate with grid, diesel, and battery power, were to not receive power from any of these three sources? In this situation, the hybrid solar plant will not generate solar power. If, however, any of these three sources of power are present, be it grid power or battery power or diesel power, the solar plant can still generate electricity and supply the load. No matter what kind of solar plant you need, the solar panels are the same. It is the inverter that is different. The inverter is the brains of the solar plant, and how the plant functions is governed by the inverter. The three types of solar plants boil down to three types of inverters. The grid-tied inverter that integrates only with grid power, the off-grid inverter that integrates only with batteries or diesel power but not with the grid, and finally the hybrid inverter that can integrate with grid power, diesel and battery power. A solar PV plant will last 25 years and the inverter can last 10 years or even longer. It is therefore important to choose an inverter keeping in mind both current and future requirements.